Live, going. We're live! Math 60, intermediate algebra, polynomials, multiplication, and now the big excitement is the F word. Yes, you heard it first. This is the F word, FOIL. Woohoo! So this is the shortcut for multiplying two binomials. Let's talk about what it means, what it feels like. Interview it. What does it eat for lunch? Probably a watercress sandwich. Let's try this out. I know if you don't know what a watercress sandwich is, you are missing out. X plus 2, x plus 3. Now, the way we were doing it before is I'm going to take the first binomial and split it up. This x times the x plus 3, and this 2 times the x plus 3. Let me give this a minute to dry. So well, that's okay. A good smearing scares everybody away, and then you don't have to deal with humans, and you could just do math 24/7. In fact, you could find yourself a nice attic and just do math for the rest of your life. That sounds like fun, doesn't it? Okay, so the x and the 2 get split up. Each of them multiply through the x plus 3. So what does that look like? Okay, so the x goes multiplying through. I get x times x plus x times 3. And then the 2 goes multiplying out. 2 times x plus 2 times 3. Now, someone had a brilliant idea. And they said, wait, what if, since this is always going to go the same way, what if we could memorize a pattern? And that pattern would help us do this without having to do all this setup and highlighters and all that sort of thing, especially because the great highlighter shortage of 1948 was pretty terrible. No one was doing math for months until someone realized you can do math without highlighters. Okay, so here we go. If I notice the x times the x came first, so here's my first combination. And because this x and that x are each the first of their respective binomial, I say first. Oh, and I'm totally going to use up all the space from everybody else. That is the way we do it. X times 3. Let's take a look at what's going on. The x times 3 is these two together. That's the second one. Now, this is the first one. That's the last one. So they couldn't call it the first last. I mean, they could have. That would have been cool. That's what I would have called it. But, most people would balk at that. So what they decided to do is they called it the outside or the outer. Outside or outer. It gets said both ways. Then the 2x, well, that's these two. That's the third combination. 2 times x, there we go. That's the inside or the inner. And then the last one, the fourth of these 4, this fourth one, it's the 2 and the 3. So they're respectively the last ones in each of their binomials. So we call it the last. And conveniently, this is actually a word in English, FOIL, first, outside, inside, last, or first, outer, inner, last. That's the pattern you memorize. Now, I will tell you, they had not invented patterns. We had no patterns back in the 70s and 80s. We just had to learn math without any sort of catchy things. We just had, basically cuneiform and those little clay tablets and not much else. And so this is a revelation to me. But you don't need to use it. You could totally keep multiplying if you're happy with your multiplication. The reason that FOIL is useful is 2 things happen. One thing is your brain gets really fast at this pattern. The second thing that's going to help you with is, and I hate to break the bubble of the party that we're having right now, but the very next thing we're going to be doing in the next section is going backwards. We're going to be unmultiplying, which is also known as dividing. We're going to be factoring out. And so if you memorize a formula like this, you get your brain starting to really pay attention to the patterns, then it's going to have an easier time going back. So, shall we use FOIL? Yes, let's use FOIL. Oops, sorry. Woohoo! Oh, there's excitement from the peanut gallery. Oh my gosh. I know we're supposed to be like pretending like the whole world doesn't exist, but you have no idea. Someone is making me dinner right now. It smells so good. I'm about to eat my pen. Okay, so obviously the live studio audience is enjoying math as well. So using FOIL, we're supposed to multiply these out. So basically the way this goes is someone will usually write out FOIL. We do this right here, FOIL. And then you try to figure out, okay, first is going to be the two that come first. So this is 2x. Oh, there's a little x there, and negative x. Oh my goodness, my hunger has made me forget all the math. We don't say negative x, we say the opposite of x. I'm so sorry. 2x times the opposite of x. O stands for outside. Let me put this in a box because otherwise it looks like outside O. And first if. Okay, so O is going to be the 2x and the negative 3, the ones on the outside, so that direction. So that'll be 2x times negative 3. I for the inside or the inner, that's those two that are touching in the middle. That's going to be 4 times the opposite of x. See, I got it right that time. And L stands for last, which is going to be these two last ones, 4 times negative 3. So if you just pair them like this, for first, outer, inner, last, negative 2x squared minus 6x minus 4x minus 12. And then the only thing you have left to do is if there are any like terms, combine them. Negative 2x squared minus 10x minus 12. Let me move this over so you can actually see that. Ooh, even better when you can see what I'm doing. And there you go. That is the shortcut for multiplying two binomials. So you might ask me, are there shortcuts for larger polynomials? And the answer is I have not found one. I have been looking. The nice thing about FOIL is there are 4 letters, there are 4 terms. Oh, sorry, 4 terms right there. So it makes it a lot easier. So I don't know of any mnemonics for the larger ones. And to be honest, most of the time when we're multiplying and factoring, it's going to be with binomials. So this is going to be really helpful. So shall we try again? Okay, so let me give you an FOIL right here out of the splash zone. Let's come back over here. So first, 3x times x. Outer, 3x times negative 2. Inner, negative 3 times x. And last, negative 3 times negative 2. So I see 3x squared minus 6x minus 3x plus 6. So it's 3x squared minus 9x plus 6. Woohoo! There we go. And again, if you already know how to do this, then what you want to be doing is really focusing on how to go from this back to the original question, because that's going to be the next section. So you want to really know this forwards and backwards. That's the way we're going to be working on it. Now, there are a couple of interesting patterns we can follow. For example, what if we multiply the same binomial times itself? So notice that this would be x plus 2 the quantity squared. That's an interesting pattern to look at. So let's go ahead and get ourselves the FO and the I and the L, FOIL. You can also do FEAL if you like. You can switch the O and the I, and it won't change much at all. First is going to be the 2 that start off, so that's x times x. Outside, that's the x and the 2 on the outside. Inside, oops, sorry about that. Inside, those are the two that touch in the middle, 2 times x. And last are going to be the two last ones. That's 2 times 2. So interestingly, everything's kind of matchy-matchy because I've got two binomials that match. And I end up with x squared plus 2x plus 2x plus 4. That's x squared plus 4x plus 4. I'm going to tuck that into the back of my head, and in like a minute and a half, we're going to come back to that. So that was interesting. Now that was interesting. It's called the square of a binomial. It sounds very fancy. Square of a binomial. The square of a binomial. I know, you can impress the family and friends. The next one, though, is the fun one. I love sums that are called telescoping, in that they shrink. And because I'm going to be able to use my favorite math noise, which goes like that. I love it. So let's talk about why the heck my tongue is doing that right here. Oop, don't pay attention to what's coming next. Don't worry about that. So let's look at FOIL for this one. I think those might be too close, but let's give it a try. So right here, first is going to be x times x. Outer is going to be x times -3. Inner is going to be, again, the touching ones, 3 times x. And last is 3 times -3. So I get x squared plus 3x. Oops, sorry. This first one is minus 3x. I lied. Minus 3x plus 3x minus 9. Sorry about that. Let me write it again so it's easier to see. Now, why is this different from the previous one? Well, the reason this one is different from this one is that this had 2 pluses. And this one has 1 plus and 1 minus. And what that did was, in the middle, we end up with 1 plus and 1 minus. And now we can make the noise. We made it disappear. The 3x's minus 3x plus 3x are gone, and all we've got left is this guy. Those of you who've taken algebra before will recognize this is a difference of squares. Okay, so let's actually write these out as formulas. Here's the thing. As far as my class is concerned, you are welcome to memorize formulas, and you are also welcome just to do the work, whichever is faster, whichever is better for you. The one thing that I can recommend about formulas is that if you do memorize the formula, then you will, your brain will have an easier time recognizing it when you have to unravel it, when you have to factor. So I would recommend looking at the formulas and working with them, but ultimately, if they do not help you, then let them go, with the exception of anyone going to calculus. If you are heading to calculus, well, oh, good luck. You have to know everything about everything to go into calculus. So calculus is the Greek word for, oh my goodness, you are so not prepared for this. So, okay, but don't worry about it. It's lots of fun. You'll enjoy it. Most people survive calculus 1. Okay, so here's our formula. The square of a binomial. Square means you multiply it times itself. Binomial means 2 terms. Remember, this is just straight up math. Mathematicians love to name things the most boring, precise thing ever. So they're going to name things exactly what they are. No flourishes, just straight up gruesome square of a binomial. So let's take a look. I've got a plus b times a plus b, right? So they are binomials and they match. This is a plus b, the quantity squared, right? So let's put out our f, our o, our I, and our l. So first is the a times the a. Yay. Outer is the a times the b. Inner is the b times the a. Last is the b times the b. So I've got a squared plus ab plus ba plus b squared. But then I realize a squared plus ab plus ba, because this is multiplication, can also be written as ab. So I get 8, oops, Sorry, giving away the answer. I get a squared plus 2ab plus b squared. That is this formula for the square of a binomial. That is the thing that is, it's worth it to memorize that that's what this equals. I feel like I should put that somewhere formally. I think I did. I have it on another formula page. So that is the formula for the square of a binomial. A plus b, the quantity squared, equals a squared plus 2ab plus b squared. It's kind of pretty. It's kind of balanced in an interesting way. It's kind of nice. And why do you get 2 times ab? Well, because you get the o and the I. So the oi gives you 2 of them. They match. Okay, so what happens if you... Now, this is certainly my entry for the possibly ugliest phrase description of a problem. The product of a sum and a difference. There's the sum, there's the difference. It's true. It's ugly. It's gruesome. It's math. So, F-O-I-L. Notice that in this case, nothing is squared because they don't actually match. First, A times A. Outer. Now it's a little bit different. It's A times the opposite of B. Inner, B times A. Last, B times the opposite of B. So let's see. That's A squared. I'm running out of space. Let me move you up. A squared minus AB plus BA minus B squared. So that's A squared minus AB plus AB. Remember, I'm allowed to rewrite it in the other order because it's multiplication. Minus B squared. And what happens in the middle? Right? It's like an old-fashioned telescope. It gets smaller. So our final result here is A squared minus B squared. That is the product of a sum and a difference will give you this difference of 2 squares. Okay, woohoo. So we're in the home stretch. I've got one more lecture on multiplying polynomials, and then we will go ahead and get started on factoring polynomials, everyone's favorite. Not. See you soon. Woohoo. Okay, that took a long time.